Bismillahirrahmanirrahim. Hello everyone. My name is Fahim Ahmed Gul and I am your lecturer. In this semester we will study two courses. The one is called Principle of Concrete Structure Design and the second one is Soil Mechanics and Foundation. Let me introduce myself. I did my master's in structural engineering from KUST, Islamabad, Pakistan, and my bachelor's degree in civil engineering was from Sood, Peshawar, Pakistan. I'm holding 6 years of total experience, 4 years in teaching and research, and 2 years of professional experience. Means I did work for 2 years in companies. My research area is comparison of plain concrete and glass fiber reinforced concrete beams with different flexure and shear reinforcements to enhance the mechanical properties for betterment of the structures. If anyone interested in future to do a research or related any topic, they can contact me personally. The books which I am referring you for this course, the one is Principle of Concrete Structure Design, which is edited by Y. Fa Chen and Eric M. Louis. The another one is Principle of Concrete Structure Design by Ram S. Gupta. The third one, the most famous book which I am also following, Design of Concrete Structure Design by H. Nielsen, David Darwin and Charles W. Dolan. You can follow any book from these three, but I am focusing or I am following this third one. And this whole degree I will teach you 3 courses related to the design. The first one which we are studying in this course in this semester, that is Principle of Concrete Structure Design, and the rest 2 courses will be studied in the coming 2 semesters. The second course is Concrete Structure Design and the third course is Anti-Seismic Structure Design. What is the difference between these courses? I will explain all these things, and what are the contents of Principle of Concrete Structure Design. Everything will be studied in this lecture. What will be the learning outcomes from this course? At the end of this course, the student will be able to understand the physical and mechanical properties of reinforced concrete materials. Through learning this course, students can master the basic theory and basic knowledge of concrete structure object. The physical and mechanical properties of concrete structure materials, the basic principle of concrete structure design, providing a solid foundation for studying concrete structure design, and after graduation, learning in reinforced concrete structure subject. All these things will be learned from this course. These are the course outline for Principle of Concrete Structure Design, which are enlisted by the management of NIT. The first one is Introduction to Principle of Concrete Structure Design, then Mechanical Properties of Reinforced Concrete Structure Design, the Basic Design Principle of Concrete Structure, Normal Section, Bending Member, Oblique Section, Compression Member, Bearing Capacity, Tensile Capacity Calculations, the Bearing Capacity of Torsion Member, Deformation and Cracks, Pre-stressed Concrete Members. All these things will be studied in this course. Let me explain you few things related to this course, and what we will study in this course, and what we will study in the next coming courses. See, the first course, that is named as Principle of Concrete Structure Design. The short name we call it PCSD. In this course, the students will learn the manual design of a single story building. In this course, what students will learn? Manual design of a single story building, and this design will be a gravity design. This design will not be for earthquake resistant designs. You basically know about what is earthquake, what is seismicity, all these things maybe you know. And the second course, that is concrete structure design. In this course, what we will study, the same project, same design. I will assign you a project in this course, like 3x3 span of a building, 60 feet in this direction and 60 feet in this direction. You will design this single story building by the assigned loads. But in the next course, which we will study in the coming semester, that course is about the same kind of project which I am assigning you in this course. The same project will be designed in the next semester, but in next semester you will study the same design on software based design. But this building will be a 4-story building, and this design will be a anti-seismic structure design. And the third course, that is anti-seismic structure design. In this course, we will just study few new things related to performance based design. With the passage of time, you will learn all these things. But remember, you will have to design a manual design of a single story building in this course. Your marking criteria for this course, that is design is shown in this screen. You will have to submit 2 assignments. Both assignments will contain 5 marks. The total weightage of these 2 assignments is 10% marks in a total of 100 marks. You will have to submit, or you will have to give me 2 quizzes, 5% marks, and the weightage of these 2 quizzes will also be a 10%. And the third one, that is Viva quiz presentation, and you will have to submit a report of a complete project. It will also contain 10% marks, including your attendance marks, and the weightage of this report and attendance, that is 10% and a total of 100%. means the section marks will be of 30% marks, and your final exam will contain 70% marks and a total of 100% marks. When you will submit these things in which week? Let me introduce. Assignment number 1 should be submitted in week number and will be announced in week number 4, and it will be due in week 6. Assignment 2 will be announced in week 8 and will be due in week number 10. Similarly, quiz 1 will be announced in week 6 and it will be due in week 8, and quiz number 2 will be announced in week 8 and it will be due in week 10. Your viva, quiz, presentation, or you need to submit a report of your project, all these things will be announced in week 10, and you have to submit it in week 12 before ending of this semester. And the final thing, that is final exam, it is to be decided. We don't know the final date of the final exam. Well, let's start with first chapter, Introduction to Principle of Concrete Structure Design. What we will study in this chapter: the basic concepts, concrete basics, properties, concepts and composition, basic concept of reinforced concrete, development of reinforced concrete. All these things will be studied in this chapter. Hope you all know about what is concrete. It's a mixture of cement, water, coarse aggregate, fine aggregate, and sometimes it mixtures if required. This mixture is called basically a concrete. Why we use concrete, where we use concrete, you all know about this. The aim is to mix these materials is measured amounts to make concrete that is easy to transport, place, compact, finish, and which will sit and harden to give a strong and durable product. Concrete is basically used. Before using a concrete, what we will use? And old era we were using soil instead of concrete, and now in the modern time we are using concrete as the strongest and durable material. The amount of each material, cement, water and aggregates, affects the property of the hardened concrete. If you increase the cement, you can increase its strength and durability. If you increase water, you can compromise on durability and strength. If you increase aggregates, you can also increase or decrease its physical properties. Concrete mixing is done by the following method. A concrete mix is designed to produce concrete that can be easily placed at the lowest cost. The concrete must be workable and cohesive when plastic, then set and harden to give strong and durable concrete. Concrete must be workable and cohesive when plastic state, when it is in the form of plastic. After some time, it will get set and hardened to give you a strong and durable concrete. The mix design must consider the environment that the concrete will be in. If you are a site engineer, you have to consider the environmental conditions of that area, that where you are going to do a project. For example, if your project is exposure to seawater, trucks, cars, forklifts, foot traffic, or extremes of hot and cold area, the cold area like a Harbin, or the hot area like, for example, Nanchang is also a hot area. So you have to consider these environmental conditions when you are designing a concrete mix design. Proportioning of concrete. What is it? Proportion of concrete is a mixture of cement, water, coarse and fine aggregates and admixtures. The proportions of each material and the mixture affects the properties of the final hardened concrete. These proportions, best measured by weight, measurement by volume is not as accurate but is suitable for minor projects. Do you know the mixed design ratios? Let me show you. For example, for beam and column, we usually use 1, 1.5, 3. What is this one? Is cement. This is 1.5. Fine aggregate. What is this? Coarse aggregate. By increasing or decreasing these proportions, the physical properties of the concrete can be changed. For different structure members or for different types of structures, these proportions may vary. For example, for slabs or floors, what we are doing, we are using a concrete proportions of 1:2:4, and sometimes we also use 1:3:6 for the area which is not for the heaviest use of heavy loading. But if you are using for the heavy loads, or we want more strength and more durability, we will go for this proportion or this type of proportion. And all these things you will study in a code that is ASTM. For different projects, you can know about these proportions. What is ASTM? ASTM is American Society Testing Materials. What does it mean? American Society of Testing Materials. American Society of Testing Material proposed a code, a complete book for the reference of the concrete properties for different types of structures. Concrete ingredients. Basically, concrete have three main ingredients, and the third ingredient is divided into two parts. The first one is cement, second is water, and third is aggregates. We have two types of aggregates: coarse aggregate and fine aggregate. What is fine aggregate? Fine aggregate fine aggregate is basically a sand, and coarse aggregate is a broken stones. What is cement? Cement is a content. If you increase it, so you can increase strength and durability. If you increase the cement content, we can increase strength and durability. Therefore, to increase the strength, increase the cement content of a mixture. What's water content? Adding more water to mix gives a weaker hardened concrete. If you add more water in a concrete mix, you will get a weaker concrete. The strength will be very less. Always use as little water as possible, only enough to make the mix workable. Usually what we do, we use water the half of the cement, but AS team will tell you in detail. But if you want to know, or if you don't know about ASTM standards, then you can simply use half of the cement. For example, the cement is 1 kg, then you need to use water half liter, and the same mixed design. What's water to cement ratio? As water to cement ratio increases, the strength and durability of hardened concrete decreases. If water cement ratio increases, strength and durability of hardened concrete will what? It will decrease. So usually for different types of structures and for different types of concrete strength structure members, you need to use ASTM standard to follow the specific water cement ratio. When I was designing my own uh, beams for my research, then I was at that time I've used 0.7 water cement ratio. Usually it ranges from 0.5 to 0.75, I guess. To increase the strength and durability of concrete, decrease the water cement ratio. If you want more strength and durability, you need to decrease water cement ratio. Aggregates too much. Fine aggregate gives you a sticky mix. It will stick. It will not be that much workable. And too much coarse aggregate gives you a harsh or bony mix. If you want to give the desired properties of the concrete, then you need to focus on all these things. The concrete mix should be workable so that it can be placed and consolidated properly by the workman. Hardness, cohesiveness, and strength. Concrete must be resistant to freezing, thawing, watertight, non-permeability, wear resistant, and strength. If your concrete is not resistive to all these things, then it will be a waste. Economy, obviously economy is the most important factor. Since the quality mainly depends on water cement ratio, the water content or the water requirement should be minimized to reduce the cement requirement and hence cost. If you control the water requirement, you can minimize the cement requirement. Obviously cost will be reduced, or you can control it. There are two things on which the complete project cost matters. The first one is cement and the second one is steel. Your complete project cost depends on these two things, cement and steel. If you use more steel, more cement, obviously your structure will be maybe a durable, but it will not be economical. That's why we need an optimum design. What is skewering? Have you ever seen that when the newly concrete is poured and after 1, 2 or 3 hours it cracks, or sometimes it blasts? Why? Why concrete cracks after pouring and why it blasts? Because of dehydration. Cement is a mixture of different chemicals. When it reacts with water, it exhausts some gases, and because of exhaustion of the gases, concrete blasts, concrete cracks. How to control this? Only one technique that is available, that is curing. There are different types of curings available. We will study all those curings in the next course, but over here I'm just giving you the overview. Curing is the necessity to get better quality structures because the cement requires time to fully hydrate before it acquires strength and hardness. Concrete must be cured once it has been placed and achieved initial setting. When the initial setting is achieved, concrete should be cured. And curing can be done for different time periods. It can be 7 days, it can be 14 days, it can be 28 days. It depends on your requirement, on the project requirements. Curing is a process of keeping concrete under a specific environmental condition until hydration is relatively complete. When the hydration is completed, you can remove that specific environmental condition. Good curing is typically considered to provide a moist environment and controlled temperature. Good curing is typically considered to provide a moist environment. Can you understand from this point? If you providing a good curing, you are creating a moist environment around your poured concrete in a controlled temperature. A moist environment promotes hydration, since increased hydration lowers permeability and increased strength, resulting in a higher quality material. Allowing the concrete surface to dry out excessively can result in tensile stresses. If the concrete surface after pouring is dry out excessively, what will happen? It will result in building of tensile stresses, which will still hydrating interior cannot withstand, causing the concrete to crack. That's why cuvening is most important for every project. What is reinforced concrete? Reinforced concrete is a concrete in which reinforcing bars or other types of reinforcement have been integrated to improve one or more properties of the concrete. There are different properties of concrete: tensile strength, compressive strength, flexural strength. You better know about that, or may you have already studied this thing in your previous courses. There are basically three types of concretes: plain concrete, reinforced concrete, fiber reinforced concrete. Plain concrete. Plain concrete is a mixture of these things like cement, sand, coarse aggregate, water. Reinforced concrete: cement, sand, aggregate, water, and steel. What is fiber reinforced concrete? Cement, sand, aggregate, water, steel, and fibers. What is the benefit of this concrete? It is strong and compressive strength. But weaker in tensile strength. If we want to achieve this tensile strength of the concrete, what we will do? We will incorporate this material with the steel. Strong in what? Strong in tensile strength and compressive strength. Plain concrete have one drawback, that is it is weaker in tensile strength, but it is stronger in compressive strength. And reinforced concrete is strong in tensile strength and compressive strength, but still when the earthquake comes, when the earthquake hits your building, structure still fails. That's why researchers in all over the world produced a new concrete, that is fiber reinforced concrete, and my research is also on this topic. Different types of fiber reinforced concrete are available, and we will study all these things in the next chapter. So you better know about reinforced concrete now. Reinforced concrete is a concrete in which reinforcing bars or other types of reinforcement have been integrated to improve one or more properties of the concrete. Concrete is a good and compression state with and weak in tension. For both compression and tension, reinforcement is provided to strengthen it to take enormous loads and have a composite structure. As I told you before, reinforced concrete is a modern day way to produce high caliber and complex buildings with combination of columns, beams and slabs. How we develop reinforced concrete? The art of science of concrete construction has a long history, dating at least to ancient Rome. The development of reinforced concrete, on the other hand, is relatively recent, being scarcely 100 years old. Concrete construction has a long history. As from the ancient Rome, we are using concrete constructions, but reinforced concrete construction is quite new, approximately 100 years old. Numerous men and organizations in Europe and United States have made major contribution to the understanding and use of reinforced concrete. One of them is as follows. Jean Monnier, a French gardener, has first used reinforced concrete wire nets in 1867 for durable tree and flower pots. He used this concrete for what? Durable tree and flower pots. Later in 1870s, he obtained reinforced concrete pipes, reservoirs, floors, straight and arched beams and bridges for the ease of the people. If you have any question, you can ask me on WeChat or anywhere, even on YouTube. I will try my best to give you the best answer. Our first chapter is completed here. Let's start your next chapter, chapter number 2. Chapter number 2 contains this content, and the name of chapter number 2 is mainly dependent on mechanical properties of reinforced concrete material. And the content which we will study in this chapter, that is plain concrete, reinforced concrete, fiber reinforced concrete, mechanical properties of reinforced concrete. What's concrete is we have studied in the previous chapter. Let me explain again. Concrete is a mixture of few ingredients, that is cement, water, coarse aggregate and fine aggregate, and sometimes admixtures if you required. Why we add admixtures? Usually we add some admixtures to get rapid hardening, or to make it dry very fast, like that. The aim is to mix these material in measured amount to make concrete that is easy to transport, place, compact, finish, and which will sit and harden to give you a strong and durable product. The amount of each material, that is cement, water and aggregates, affects the properties of hardened concrete. If cement, water or aggregate increase or decrease, it will affect your physical properties of the or mechanical properties of the concrete. A heavy rough building material made from a mixture of broken stone or gravel, sand, cement, water, that can be sprayed or poured into molds, and that forms a stone-like mass on hardening. That is also called a concrete. These are the two main definitions. You can use any one of these. We know that concrete is a brittle material. What is brittle? Brittle is a material like glass. It will not gives you any kind of warning. When you apply load on it, it will suddenly breaks like this. It's a glass. This is a brittle material. If I apply load on it, it will suddenly break. It will not give me any kind of warning. But this pin is a ductile material. Before breaking, it gives me warning. It will provide some bending. So that's why we need fiber reinforced concrete and reinforced concretes. So we know that concrete is a brittle material. It is weaker in tension and stronger in compression. That is why the necessity of reinforced concrete happens to cater such kind of problem. Which kind of problem? To enhance the tensile strength of a concrete. Reinforced concrete. What is reinforced concrete? As I told you before, reinforced concrete is a mixture of cement, sand, aggregate, water and steel. Reinforced concrete is in which steel is embedded in such a manner that the two materials act together and resisting forces. Can you see this picture? Two material, concrete and this is steel. These two materials are acting together against the applied forces. The reinforcing steel rods, bars or mesh absorbs the tensile, shear and sometimes the compressive stresses in concrete structure. Plain concrete does not easily withstand tensile and shear stresses caused by the wind. Do you know what is tensile stress? Tensile stress is to provide the elongation in any material that is tension. You are providing tensile forces. But shear, you know about the friction. Friction is one thing. Let me explain. This friction. Can you see my two hands? Friction. One hand moves in this direction, another hand moves in this direction. When you move in these two opposite directions, you will face a kind of force between these two surfaces. It's called frictional force. And the area which is affected by these two opposite direction of applied forces, that is shear zone, and you are applying basically a shear stresses. These shear stresses and frictional force are approximately the same thing. So plain concrete does not easily withstand tensile and shear stresses caused by wind, earthquakes, vibrations and other forces, and is therefore unsuitable in most structure applications. Vibrations can be a machinery vibrations. And reinforced concrete, the tensile strength of steel and the compressive strength of concrete work together to allow the member to sustain these stresses over a considerable spans. Now, what is fiber reinforced concrete? As I told you before, fiber reinforced concrete is a mixture of the same reinforced concrete but additional of fibers. There are two types of fibers available. Natural fibers and artificial fibers. Natural fibers are those which are abundantly available in this world. Artificial fibers are made by human beings or any kind of machineries. There are few examples of natural fibers like hair fibers, bamboo fibers, similarly coconut fiber, etc., etc. And artificial fibers are glass fiber, polypropylene fiber, nylon fiber, steel fibers, and over here one more I remember, asbestos fiber. So these are the few different kinds of fibers available. Even my research was on GFRC, glass fiber reinforced concrete. So these are the basic. If any kind of questions comes in your quiz or paper, that what name the different natural fibers or artificial fibers, so what will you do? You will name these different types of fibers. Stress structure faces the failure. That's why we need fiber reinforced concrete. Therefore, the researchers all over the world are started to work on fiber reinforced concrete. Concrete is relatively brittle and its tensile strength is typically only about 1/10 of its compressive strength. It is just these two lines are for plain concrete. Concrete is basically what? A relatively brittle and its tensile strength is typically only about 1/10 of its compressive strength. Concrete is therefore normally reinforced with steel reinforcing bars. For many applications, it is becoming increasingly popular to reinforce a concrete with small randomly distributed fibers. Their main purpose is to increase the energy absorption capacity and toughness of the material, but also increase tensile and fracture strength of the concrete. What is energy absorption and what is toughness of the concrete? Energy absorption is basically what? Sometimes when you apply load on a fiber reinforced concrete member, if what will happen an actual phenomena, concrete will fail first, then the second will be steel will fails, and then third fibers will fail. So when concrete is already cracked, the load, the structure will not collapse, it will still sustain, it will give some kind of warning, because the load at that minimal time, that load will be taken by the fibers present inside the concrete. Therefore, main purpose to increase ending the fibers in the concrete, that is energy absorption and toughness of the material, but also increase tensile and fracture strength of the concrete. FRC historical aspect and BC horsehair, 1900 asbestos fiber and Hatchett process, and 1920 Griffith theoretical widths apparent strength, and 1950 composite materials, in 1960 fiber reinforced composite, in 1970 new initiate for asbestos cement replacement, in 1970 SFRC steel fiber reinforced concrete, glass fiber reinforced concrete, polypropylene fiber reinforced concrete, and shotcrete. All these things have been used. Do you know about shotcrete? Shotcrete is basically a technique which is used in tunneling when we are excavating the tunnel inside a okay, shotcrete is basically a technique which is used for tunneling. When we are excavating a tunnel inside a mountain, you will see a hole is means when you apply explosive material on the mountain and it's excavated and makes a hole inside a mountain, then what will happen after that? You will see material is falling down from the top surface of the mountain. How can we stop it? We will use a shotcrete technique. What is shotcrete? Shotcrete is basically a mixture of concrete, soft concrete with steel fibers. We push the concrete and we shot this concrete on that surface, on the affected surface, so that the material will not fall down further. A machine is used for it which shots the concrete at some distance. In 1990, micromechanics, hybrid systems, wood-based fiber systems, and manufacturing techniques, secondary reinforcement, HSC, ductility issues, shrinkage crack control, all these things in 1990 researchers and people have worked on it. 2000 plus structural applications, code integration in new products. Areas of application of fiber reinforced concrete. This is one of the best example, which is located in California. FRC glass fiber reinforced concrete project at Trillium Building, Woodland Hills. It's located in California. Even fiber reinforced concrete can be used for thin sheets, shingles, roof tiles, pipes, prefabricated shafts, panels, shotcrete, curtain walls, slabs on grade, precast elements, composite decks, wall safes, impact resistant structures. These are the applications over where we can use fiber reinforced composite materials. Fibers of various shapes and sizes produced from steel, plastic, glass, natural materials are being used. However, for most structure and non-structural purposes, steel fiber is most commonly used of all the fibers. There is considerable improvement in the post-cracking behavior of concretes containing fibers. Although in the fiber reinforced concrete, the ultimate tensile strength do not increase appreciable, the tensile strengths at rupture do. Compared to plain concrete, fiber reinforced concrete is much tougher and more resistant to impact. Do you know impact loading? Impact means this type of loading. You are applying this type of loading. This type of loading is an impact. Means compared to plain concrete, fiber reinforced concrete is much tougher. It can bear more load as compared to plain concrete. When you are for the impact load, it will perform better instead of plain concrete. These are the different sizes and shapes of plain concrete. They are the different sizes and shapes of steel fibers. Steel fibers of different shapes and sizes are shown here. This A picture means straight, smooth, drawn wire steel fibers. This B means deformed, crimped wide steel fibers. This C means this one variable cross section steel fibers, and this fourth one is glued bundles of steel fibers with crimped ends. Types of steel fibers. This is straight, hooked, pedaled, deformed, crimped, and irregular. Structures and different types of structures, different type of researches. Researchers prefer these all the fibers instead of straight fiber. Steel fibers glued together prior to mixing. Can you see this one? it is glued together. All these types of small fibers glued together in the form of sheets. Separating of fibers occurs during mixture to ensure uniform distribution. If you have any question regarding these two chapters, you can ask me. I am available to give you the best answer. Well, thank you. This was our new. This was the first two chapters, and your project will be announced in chapter number 4. Hope you have understand this two chapters. If you have any question, you can ask me anytime on WeChat or on YouTube. Thank you.